Hi everyone, Emma here from ClusterWare. Today is the perfect day to make your application more resilient. Get ready for an exciting journey where we're going to smash the single point of failure in our infrastructure. Here is an example setup that I have used in previous demos, and the bottleneck is pretty obvious here. Of course, when the load balancer is down, no customer can use our service. So let's fix this. In today's presentation, we're going to add a second load balancer under the same host name. In the event of the first one going down, the second one will immediately take over to ensure your service stays up no matter what. I'm not just talking theory, we're about to witness how quickly the traffic switches between the load balancers by removing the APP2 server from the ALB and attaching it to the failover ALB only. In a typical situation, we'd want both load balancers to route the traffic to all applications in the cluster. However, by splitting them up, we'll clearly see which app is serving our request. Okay, so let's get into it. First, we need to onboard one more server that will host our second load balancer. I'm going to name the server Failover ALB. I need to paste the server host name, provide the username, and click Save. On the next screen, I have the instructions on how to onboard the server to ClusterWare. Now, I'm going to open my terminal on the side to SSH into the server and authorize the access. Now I can click Done to sync the status of my server with ClusterWare. In the meantime, I'm going to navigate to the Software tab and enable Install Update Mode on my new server. The only thing I need here is to install Nginx under the load balancing section. So I'm going to hit Install Nginx, provide the root password, and wait a few seconds for the changes to take effect. Perfect. Now let the load balancers unite. As I described in the introduction, we want to have one host name that points to both load balancers so that customers are delighted regardless of which load balancer is serving the request. But currently we have two separate host names, each pointing to a different load balancer. To fix this, we need to add a new DNS alias pointing to both servers. This is a crucial step, so please stay with me. Depending on your DNS provider, the configuration process will look slightly different, but here is a summary of what we need to do. For demo purposes, I'll name the alias VIP Party. It might sound technical, but trust me, it's party time. Now you need to add two A records in your DNS configuration. The first one pointing to the IP address of the ALB server, and the second one pointing to the IP address of the failover ALB server. To check if I configured the DNS records correctly, I can run a dig command in my terminal, passing my new alias as an argument. Here, in the answer section, you can see that my VIP Party domain points to two IP addresses, so we're all set. Perfect. Now it's time to configure the load balancers. Let's update the existing load balancer first. All we need to do here is update the hostname to use our new alias. And secondly, as I mentioned in the introduction, we'll remove the APP2 server from this load balancer and attach it to the second one in the next step. So now I can click Save and add the second load balancer. The failover ALB will be the server hosting it. Now, the default host name points to the host server only. So I'm going to overwrite it and provide my VIP Party alias here as well. And lastly, my new load balancer is going to use the APP2 application endpoint only. Okay, so now I can click Save and restart both load balancers. I need to provide the root password for each as they're running on different servers. The root password for the failover ALB was already remembered by ClusterWare for the browser tab lifetime as I was installing Nginx in the previous step. If you configured your endpoint security or gateway security following my previous demo, you can pause the video now and set it up for the new load balancer, just as we did for the first one. Okay, fantastic. As we now have the two load balancers running with the same hostname and we have the DNS configuration done, we can run our experiment. Let's click on the load balancer URL first. I have a simple script that I used in the first episode to call the load balancer endpoint every 500 milliseconds so that you're able to see which load balancer is serving the request. The requests are currently served by the first ALB server, as the port number in the response is 8000 and 8001. Let's see what happens if I take this load balancer down. I'm selecting the Stop this load balancer option and going back to the Experiment tab to see what happens. And there we have it. The traffic has seamlessly shifted to the failover ALB with no downtime. And as expected, the requests are now served on port 9000 and 9001 only. Okay, huge thanks for tuning in. If you're hungry for even more resilience, check out other options, including GSLB or a cell-based architecture. Don't forget to dive into ClusterWare with the step-by-step guide in the video description to eliminate a load balancer bottleneck in your architecture. Check out my other videos on scaling, securing, and optimizing your applications. Until next time, keep rocking your app. Bye.